Okay, let's we start with our next topic, that is nutrient required for the growth of bacteria as well as the microbial growth. In previous lecture we have studied about the definition of the bacteria as well as the structure of the bacterial cell. There are various components in the bacterial cell or the different parts of a bacterial cell, that is the structure outside the bacterial cell, structure inside the bacterial cell wall, and cell wall itself, that is the structure of a bacterial cell and the functions of a various bacterial cell organisms. Now I want to study about the bacteria, that is the nutrient required for growth of a bacteria as well as the microbial growth. All of you know that for every living organism, microorganisms are the living organisms as they require the various nutrients for their growth. So basic nutrient for the growth of a bacteria, as per the composition of the bacteria, the nutritional requirement of a bacteria is very wide, and about 80 to 90% of the bacterial cell that can be made up by water. 80 ते 90% हा बॅक्टेरियल सेलचा पार्ट जो आहे तो कशाने बनलेला आहे, that is made up by water, and the major nutrient required for the growth of a bacteria that consists the hydrogen, oxygen, carbon, nitrogen, phosphorus as well as the sulfur. The trace element required for the growth of a bacteria, that is called as a micro and macronutrient. In that micro and macronutrient like cobalt, potassium, molybdenum, magnesium, calcium, iron or zinc, these are the macro and micronutrients that also required in a trace quantity, that is used for the metabolic reaction in the bacterial cell as well as the cell component stabilization. Basically the major nutrient, that is the hydrogen, oxygen, carbon, nitrogen, phosphorus and sulfur. Besides these major nutrients, some of the micro and macronutrients also essential for the bacterial growth, for metabolic reaction of the cell as well as the stabilization of the cell components, that is cobalt, potassium, molybdenum, magnesium, manganese, calcium, iron and zinc. So this is a basic nutrient requirement for growth of a bacteria. All of you know that is all organisms that can require a source of an electron for their growth as well as the survival on the basis of a source of electron. In case of a bacteria, that will be classified into the various groups, that is the lithotrophs and organotrophs. For every living organism that requires the source of electron, our classification of the bacteria on the basis of a requirement of a various nutrient किंवा sources of the nutrient, त्यामध्ये पहिला आपण पाहतोय what is the source of electron. So bacteria required the electron for their growth and survival. On the basis of a source of electron, the bacteria that can be classified into two different groups, that is lithotrophs and another one organotrophs. What do I mean by lithotrophs? The organism that can use the inorganic chemical compound as a source of an electron donor, that is termed as lithotrophs. Lithotrophs कशाला म्हणायचे? The organism or the bacteria that can use the inorganic chemical compound as a source of electron donor, that is called as lithotroph. The example of it is, that is Desulfovibrio, desulfuricans. This is an example of a bacteria that use the inorganic chemical compound as a source of electron donor. Second, that is organotrophs. Its name itself indicated that the organism that require the organic compound, or the bacteria that require the organic compound as a source of electron donor, that called as organotrophs. आपण बघतोय क्लासिफिकेशन ऑफ द बॅक्टेरिया ऑन द बेसिस ऑफ एन इलेक्ट्रॉन सोर्स. त्याच्यामध्ये दोन ग्रुप्स आहेत, लिथोट्रॉफ्स आणि ऑर्गॅनोट्रॉफ्स. इन केस ऑफ एन लिथोट्रॉफ, दॅट मीन्स द बॅक्टेरिया दॅट यूज द इनऑर्गॅनिक केमिकल compound as a source of electron donor, called as lithotrophs. An example, that is Desulfovibrio, desulfuricans, and organotrophs itself indicated that the organic compound that will be used as a source of electron donor. Okay, example, that is E. coli or Escherichia coli. Next, all organisms that also require the source of energy for their growth and survival. On the basis of an energy source, bacteria that will be classified as phototrophs and chemotrophs. Besides this electron, bacteria also require the energy and the different components that can be used as a source of energy. In that, bacteria again divided or classified into two groups, that is phototrophs and chemotrophs. What are phototrophs? Phototrophs nothing but the bacteria or the organism that can utilize light. All of you know that is photo means the light. Photo means light, that utilize the light as a source of energy called as phototrophs, and these bacteria that can be gain energy from the light. Example of that bacteria, that is the Nitrosomonas. Second one, chemotrophs, bacteria that gain energy from the chemical compounds, that is called as chemotrophs. They cannot carry out the photosynthesis. All of you know about that. The photosynthesis, in case of a photosynthesis process, light plays an important role. Light that plays the important role. So in case of a phototrophs, on the basis of an energy sources, phototrophs are nothing but the organism that can utilize the light as an energy source, that is called as phototrophs, while chemical compound as a source of energy, that is called as chemotrophs. Thus the bacteria may be either. बॅक्टेरिया कशा असू शकतात? फर्स्ट वन दॅट इज फोटोलिथोट्रॉफ्स. आता तुम्हाला लिथोट्रॉफ्स माहित आहे, ऑर्गॅनोट्रॉफ्स माहित आहे, देन फोटोट्रॉफ्स माहित आहे आणि किमोट्रॉफ्स माहित आहे. लाव द बॅक्टेरिया दॅट कॅन बी आयदर photolithotrophs. What about photolithotrophs? The bacteria that use the light as a source of energy and use inorganic chemical compound as a source of electron donor. पहिले दोन क्लासिफिकेशन आपण बघितले, ती ऑन द बेसिस ऑफ सोर्स ऑफ इलेक्ट्रॉन डोनर, ऑन द बेसिस ऑफ सोर्स ऑफ एनर्जी. मग सोर्स ऑफ इलेक्ट्रॉन डोनर वर दोन त्याचे क्लासिफिकेशन करतो जातं. कोणतं? लिथोट्रॉफ्स अँड ऑर्गॅनोट्रॉफ्स. लिथोट्रॉफ्स इज नथिंग बट that particular bacterium use the inorganic chemical compound as a source of electron donor, and organotrophs are nothing but use the organic compound as a source of electron donor. So in case of an photolithotrophs, that is the combination of an phototrophs plus the lithotrophs, means phototrophs that are known as, that is they can be used the light as a source of energy. फोटो आणि किमोट्रॉफ्स मध्ये माहिती आहे तुम्हाला, फोटो म्हणजे that use the light as a source of energy, while chemotrophs are nothing but use a chemical compound as a source of energy. So in combination, photolithotrophs are nothing but the bacteria that can be used the light as a source of energy and inorganic chemical compound as a source of electron donor, that is called as photolithotrophs. And the example of this, that is the Chromatium okenii. लक्ष देते सर्वांच्या?
हो सर.
Photoorganotrophs. Now the photoorgan. The photo means the light. Bacteria use as a light as a source of energy, as well as in organotroph, that is the organic compound as the source of electron donor, that is called as photoorganotrophs. Next, that is chemolithotrophs. What do we chemolithotrophs? Chemo is nothing but the chemical compound as a source of energy. So bacteria use the chemical compound as a source of energy and inorganic chemical compound as the source of electron donor, called as chemolithotrophs, and the example, that is the Nitrosomonas. Next, number 4, that is chemoorganotrophs. In case of a chemoorganotrophs, same like that, chemical compound as a source of energy, and another one, organic compound as a source of electron donor, called as chemoorganotrophs, and the example of that is the Pseudomonas, that is Pseudoflora. फोटोलिथोट्रॉफ्स, फोटोऑर्गॅनोट्रॉफ्स, किमोलिथोट्रॉफ्स आणि किमोऑर्गॅनोट्रॉफ्स. तुमच्या लक्षात आलंय? तुमच्या लक्षात पहिल्यांदा हे घ्यायचं की सोर्स ऑफ इलेक्ट्रॉन डोनरवर दोन क्लासिफिकेशन होतं, लिथोट्रॉफ्स आणि ऑर्गॅनोट्रॉफ्स. आता लिथोट्रॉफ्स मध्ये दॅट इज दी इनऑर्गॅनिक कंपाऊंड ऍज अ सोर्स ऑफ इलेक्ट्रॉन डोनर, आणि ऑर्गॅनोट्रॉफ्स मध्ये दॅट इज ऑर्गॅनिक कंपाऊंड ऍज अ सोर्स ऑफ electron donor. Sorry. Then photo means the light as a source of energy, and in chemotrophs, that is chemical compound as a source of energy. So combination of these, that is the photolithotrophs, photoorganotrophs, chemolithotrophs, and chemoorganotrophs. Okay. Next, on the basis of a carbon source, that bacteria again divided into two different groups, that is autotrophs and heterotrophs. As you know, all organisms require the CO2 in some form for use in synthesizing cell components. All organisms require at least a small amount of carbon dioxide. On the basis of carbon requirement, the bacteria classified into two different groups. There is autotrophs and another one, there is heterotrophs. Autotrophs are nothing but the bacteria that can use the CO2 as their major or even sole source of carbon, that is called as autotroph, or it is also known as autotrophic bacteria. Example of these autotrophs, that is Chromatium and Nitrosomonas. Heterotrophs, that the bacteria that require the organic chemical compound as the source of carbon, called as heterotrophs. An example, that is the E. coli. कार्बन रिक्वायरमेंट किंवा CO2 रिक्वायरमेंट प्रत्येक ऑर्गॅनिझमला लागते, काही का प्रमाणात तो आतमध्ये घेतो. जर ऑटोट्रॉफ, त्याचे क्लासिफिकेशन ऑफ द बॅक्टेरिया that is in the autotrophs and heterotrophs. In case of an autotrophs, when the bacteria that can be used the carbon dioxide as the major source of carbon, called as autotrophs, or it is the bacteria that can be used the CO2, that is called as autotrophic bacteria, while those bacteria that can be depending on the organic or chemical compound for as a source of a carbon, that is called as heterotrophs, and such a bacteria that can be utilized the organic chemical compound for their carbon requirement, called as heterotrophic bacteria. And the example of this, that is the E. coli or Escherichia coli. Number 4, in the nutrient requirement of these bacteria, all organisms require the nitrogen in some form for the synthesis of a cell constituent. Bacteria use the atmospheric nitrogen, some use the inorganic nitrogen, and some use organic nitrogen. All of you know that is the bacteria that play the important role in the nitrogen fixation. These particular bacterium require the nitrogen. All of you know that is the bacteria that play the important role in the nitrogen fixation, that is either symbiotic, then asymbiotic nitrogen, or the associative nitrogen fixation. So in this case, the bacteria may use the atmospheric nitrogen by doing the fixation process, or some of the bacteria use the inorganic nitrogen as well as the organic nitrogen. This is an nitrogen source. Then all organisms require the oxygen, sulfur, and phosphorus for the cell components. Bacteria also requires, that is metal ions such as K, Ca, Mg, and ferrous for normal growth. Other metals like zinc, copper, then manganese, molybdenum, nickel, boron, and cobalt are required as a trace element. The metal like ferrous, manganese, magnesium, zinc, molybdenum, and copper are known as a cofactor for the enzymes. Okay, bacteria, besides the major nutrients, the bacteria require the minor metal ions, are there, then different metal ions that can be used for the cofactors of the enzymes. All bacteria that contain the vitamins and vitamin like compound function as a coenzymes for several enzymes. Bacteria मध्ये vitamins असतात, the vitamins like compound that should be function as also the coenzymes. That likewise that is the metal ions that is cofactor for the various enzymes. These vitamins that can be play a role for the coenzyme for the different enzymes. All bacteria require the water as a solvent for the nutrient and as a chemical reactant in the hydrolytic reaction. Bacteria also require the water, and 80 to 90% of the parts in the bacteria that compose of water, and these bacterial water that can be used for the solvent of a nutrient as well as the chemical reactant in the hydrolytic reaction. Next, that is nutritional types of a bacteria. Nutritional types of a bacteria. On the basis of a nutritional types, the bacteria can be classified into 4 different groups, that is phototrophs, chemotrophs, autotrophs, and heterotrophs. What do my phototrophs? Anyone? What do my phototrophs?
Light as a source of energy.
Phototrophs is nothing but the light as a source of energy, that is called as phototroph. Nutritional types of bacteria मध्ये बघतो आपण. There are 4 different groups, that is phototrophs, chemotrophs, autotrophs, and heterotrophs. Phototrophs, that is nothing but the bacteria that can be used light as a source of energy, called as phototrophs. Photolithotrophs, light as a source of energy, then inorganic chemical compound as a source of electron donor, called as photolithotrophs. Then photoorganotrophs, light as a source of energy and organic chemical compound as a source of electron donor, that is called as photoorganotrophs. Then chemotrophs, that is chemical compound as a source of energy. Chemolitho is nothing but the chemical compound as a source of energy, and lithotrophs are nothing but the inorganic chemical compound as a source of electron donors. Chemoorganotrophs are nothing but the chemical compound as a source of energy and organic chemical compound as a source of electron donor, called as chemoorganotrophs. Then number 4, third, that is the autotrophs. That also classified into 2, that is chemoautotrophs and photoautotrophs. What do my chemoautotrophs? आता chemo तुम्हाला माहिती आहे. Chemo means what? That use the chemical compound as a source of energy, and autotrophs means the CO2 as a source of autotrophs. तुम्हाला माहिती आहे autotrophs is nothing but the major source of an carbon that is used as a CO2, or CO2 is the sole source of carbon, that is called as autotrophs. So chemoautotrophs, chemo is nothing but the chemical compound as a source of energy, chemical compound as a source of energy, and CO2 as the source of carbon, that is called as chemoautotrophs, while photoautotrophs are nothing but the light as a source of energy and CO2 as their major source of the carbon, that is called as photoautotrophs. And all of you know about the heterotrophs. Heterotrophs are nothing but they can use the CO2 that is from the inorganic chemical compound as the source of carbon dioxide. CO2 source from that used inorganic chemical compound as a source of their energy, that is called as heterotroph. Autotrophs, the bacteria which can use CO2 as a major source of carbon, called as autotrophs. Photo means CO2 as a source of carbon, light as a source of energy. Photoautotrophs. Chemoautotrophs, CO2 as a source of carbon and chemical compound as a source of energy, called as chemoautotrophs. Already we explained केले, slide मध्ये ते दिले. Heterotrophs, the bacteria that can be used the organic chemical compound as a source of carbon, called as heterotrophs, again divided into two, that is photoheterotrophs and chemoheterotrophs. What do photoheterotrophs? Same like that, utilize light as a source of energy but cannot use CO2 as a source of carbon. They obtain energy from the organic compound to satisfy their carbon and electron requirement. म्हणजे ऑर्गॅनिक केमिकल कंपाऊंड पासून ते काय करतात, त्यांची कार्बन रिक्वायरमेंट भागवतात, दॅट इज कॉल्ड एज फोटो हेट्रोट्रॉफ्स. एक्झाम्पल दॅट इज दी Rhodospirillum and Rhodomicrobium. Then chemoheterotrophs. Chemoheterotrophs obtain both carbon and energy from the organic compounds such as carbohydrates, lipids and protein. Here there are three main categories that differ in how chemotrophs obtain their organic nutrients. Chemotrophs म्हणजे काय, they obtain the carbon and energy from the organic compounds. आता chemotrophs मध्ये तुम्हाला माहित आहे एनर्जी दॅट इज सोर्स. कुणाचा माईक चालू आहे रे? Chemotrophs or chemoheterotrophs माहित आहे, that is used as a organic compound as a source of energy. आणि heterotrophs म्हणजे काय, they also utilize the organic compound as a source of carbon. So in case of chemoheterotrophs, they obtain both CO2 and energy from the organic compound like carbohydrates, lipids and protein. Chemoheterotrophs classified into three groups, that is saprophytic, parasitic and symbiotic. Now what do we by saprophytic? Saprophytes are nothing but those that can be dependent on dead and decaying material for obtaining their nourishment or the nutrient, that is called as saprophytic. And such bacteria that can obtain their food material from the dead and decaying material called as saprophytic bacteria. Saprophytic bacteria are nothing but those can be depending on the dead or decaying material, that is called as saprophytes. And those bacteria that can be utilized the particular dead or decaying material for their satisfying their nutrient requirement, called as saprophytic bacteria. Second one, that is the parasitic bacteria. What do parasitic? Parasites are nothing but those can be depending on the living host for their nutrition or nourishment, that is called as parasitic. And those bacteria that can be live on the living host, that is called as parasitic bacteria. Saprophytic म्हणजे काय, they can be depending on the dead. Parasite means they can be depending on the living host. Now third, that is the symbiotic. Symbiotic means the bacteria that can be associated in such a way that both are mutually beneficial to each other. अशा पद्धतीचं आहे स्ट्रक्चर की ज्याच्यामध्ये both these microorganisms or the bacteria and another host that will be beneficial to each other, that is called as symbiotic bacteria. What is the example of a symbiotic? That is symbiotic nitrogen fixation, that is bacteria that fix the nitrogen in case of a legume by associating symbiotically with them. In that particular case, the bacteria get the shelter in the nodule formed by the particular bacteria in the root, as well as in return they give the nitrogen that will be fixed by that particular nitrogen fixing bacteria. Symbiotic bacteria the example आहे, that is the in case of an leguminous crop that rhizobum fixes the atmospheric nitrogen. मग symbiotic relationship काय असतं, that bacteria that get the shelter in the nodule form on the legume, त्या legume वर जे nodule form होतात तिथे त्यांना काय मिळतंय, निवारा किंवा आसरा त्या ठिकाणी मिळतंय. In return they give the nitrogen that fixes by this particular nitrogen fixing bacteria to the plant, means both they can be mutually beneficial to each other. ते काय आहे, दोन्ही पण एकमेकाला mutually beneficial त्या ठिकाणी आहे. Now the next topic in this particular chapter, that is the bacterial growth curve and the growth phases. Bacteria multiply by the binary fission where the cell divides to form two daughter cells. In first lecture I will tell that is the most of the bacteria that can be reproduced by means of an binary fission. सर्वाधिक बॅक्टेरिया कशाने मल्टिप्लाय होतात, बाय मीन्स ऑफ एन बायनरी फिजन. बाय इज नथिंग बट द टू. बाय म्हणजे काय, दोन, मीन्स सिंगल बॅक्टेरिया दॅट कॅन बी डिवाइडेड इंटू द टू डॉटर सेल्स. सो द डेफिनेशन ऑफ द ग्रोथ in case of this bacteria growth, bacterial growth may be considered as the increase in the total population rather than increase in the size or the mass of an individual organism. आपण आपल्या स्वतःमध्ये किंवा सजीवामध्ये शक्यतो काय होतं, वाढ झाली असं कर म्हणतो. इफ दे कॅन इन्क्रीज इन साइज ऑर द मास, मग आपली हाईट जी आहे 1 फुटापासून 10 फुटापर्यंत झाली, दॅट इज कॉल्ड एज ग्रोथ. किंवा आपलं वजन 5 किलो पासून 50 किलो पर्यंत झालं, दॅट इज कॉल्ड एज growth. But in case of an बॅक्टेरियाच्या बाबतीत तसं नाही आहे. इन केस ऑफ एन मायक्रो ऑर्गॅनिझम द ग्रोथ दॅट विल बी कन्सिडर्ड ॲज अ इन्क्रीज इन द टोटल पॉप्युलेशन. म्हणजे 1 लाख बॅक्टेरियाच्या 10 लाख बॅक्टेरिया झाले, दॅट इज कॉल्ड ॲज अ ग्रोथ. त्याला काय म्हटलं जातं, ग्रोथ असं म्हटलं जातं. सो ग्रोथ इन अ बॅक्टेरिया दॅट इज नथिंग बट इन्क्रीज इन द टोटल पॉप्युलेशन. जे काही पॉप्युलेशन होतं, म्हणजे 100 बॅक्टेरिया आहे, 100चे 1000 झाले, दॅट इज कॉल्ड ॲज ग्रोथ. ना की 100 बॅक्टेरियाची साईज 1 मायक्रोमीटर होती, त्याची 10 मायक्रोमीटर झाली, दॅट इज नॉट कॉल्ड ॲज ग्रोथ. In case of a microorganism, growth is nothing but the increase in the total number or the total population rather than the increase in the mass or of an individual organism. The growth that denotes the increase in the number beyond the presence of the original inoculum, the bacteria multiply at a very rapid rate. The example that is E. coli, that is Escherichia coli, completes one generation in every 70 into 20 minutes at 37 degrees Celsius. बॅक्टेरियाचं मल्टिप्लिकेशन रेट कमी आहे, जास्त आहे ॲज कम्पेअर्ड टू द नॉर्मल इंडिव्हिज्युअल. समजा आपलं एक जनरेशन कंप्लीट व्हायचं असेल तर कित्येक दिवस लागतात. लाईकवाईज दॅट बॅक्टेरिया दॅट कंप्लीट दी वन जनरेशन विदिन 20 minutes, द टेम्परेचर दॅट विल बी 37 डिग्री सेल्सिअस. जर 37 डिग्री सेल्सिअस टेम्परेचर असेल तर ते ई कोलाय एक्झाम्पल दिले फक्त. ई कोलाय बॅक्टेरिया म्हणजे मोस्ट ऑफ द मायक्रो ऑर्गॅनिझम दॅट कम्प्लीट्स इट्स लाईफ सायकल इन व्हेरी शॉर्टर टाइम. म्हणजे त्याला असं 10 वर्ष 15 वर्ष 20 वर्ष असं लागत नाहीये, त्याला very short time, in the minutes. Each microorganism require few minutes to complete its life cycle, so the generation or the multiplication rate will be very rapid. This is the definition of growth. Growth ची definition आपण तुमच्या लक्षात आली. Growth in the bacteria that is nothing but the increase in the number beyond the increase in the size or the mass of an bacteria. Second definition, that is the growth curve. When bacterial cells are grown in vitro or the culture in a suitable culture medium followed by the incubation, the growth follows a particular pattern that is called as growth curve. All of you know about the cause postulate. There are 4 cause postulates are there. That is the association, isolation, inoculation and re-isolation. So in each and every place where the disease that will be occur, there is the presence of the certain microorganism. Likewise that when you want to culture, all of you know about the culture. Culture is nothing but the growth of the microorganism on the nutrient medium, that is called as culture. Culture कशाला म्हटलं जातं, the growth of the microorganism on the nutrient medium or the artificial nutrient medium in the laboratory, that is called as growth. So when you can grow the bacterial cell, in a suitable culture medium or the artificial medium, that will be followed by the incubation, means for the certain period that will be kept intact and that follows the particular period. म्हणजे एखादा ऑर्गॅनिझम तुम्ही ज्यावेळेस सेपरेट करतात. समजा लॅक्टोबॅसिलस, दह्यामधून तुम्ही एखादा लॅक्टोबॅसिलस बाहेर काढला आणि तो आर्टिफिशियली लॅबोरेटरीमध्ये एखाद्या प्लेटमध्ये ग्रो केला. प्लेटमध्ये ग्रोथ सुरू झाल्यानंतर तो काही वेळानंतर दॅट फॉलो द स्पेसिफिक पॅटर्न फॉर दी ग्रोथ. जसं इकोलायचं सांगितलं मी, 17 मिनिटात त्याची एक लाईफ सायकल कंप्लीट होते, म्हणजे तयार झाल्यापासून 17व्या मिनिटाला दॅट विल बी डिटेक्ट. Likewise that when you can culture one of the microorganism on the suitable medium, समजा बॅक्टेरिया ग्रो करायचे असेल तर न्यूट्रिएंट आगार मीडियम वापरतो. न्यूट्रिएंट आगार मीडियमवर ज्यावेळी तुम्ही बॅक्टेरिया सेपरेट करता आणि काही वेळ त्या ठिकाणी जाऊ देता, त्याला इन्क्युबेशन पिरियड म्हणतात. दॅट फॉलो अ सुटेबल ग्रोथ पॅटर्न इफ द बॅक्टेरियल काउंट आर कॅरिड आउट ॲट द रेग्युलर इंटरवल अप टू 24 hours after the inoculation and plotted with respect to time, a curve is obtained that is called as growth curve. मग तुम्ही कंटिन्युअस 24 तासाला काही इंटरव्हलला समजा एक तासानं ऑब्झर्वेशन घेत गेले. सुरुवातीला 10 बॅक्टेरिया त्या ठिकाणी ठेवल्या आणि 10 बॅक्टेरिया ठेवून तुम्ही एक तासानं ऑब्झर्वेशन घेत गेले. एक जर ऑब्झर्वेशन घेत झालं 10च्या 20, 20च्या 20, 50, 50च्या 60, 60च्या 40, 20, 10 अशा पद्धतीचा ग्राफ त्या ठिकाणी ऑब्टेन होईल. दॅट इज कॉल्ड ॲज ग्रोथ कर्व. लक्षात घ्या, ग्रोथ कर्वची डेफिनेशन, व्हेन यू कॅन बॅक्टेरियल काउंट्स दॅट कॅन बी कॅरिड आउट इन अप टू रेग्युलर 24 hours आफ्टर द इनॉक्युलेशन. मग तुम्ही एखाद्या ठिकाणी ते बॅक्टेरिया टाकल्या, इनॉक्युलेट केल्या म्हणजे काय, यू कॅन इन्सर्ट दॅट पर्टिक्युलर बॅक्टेरियल सेल. व्हेन यू कॅन इनॉक्युलेट अ बॅक्टेरियल सेल अँड द रेग्युलर ऑब्झर्वेशन दॅट कॅन बी कॅरिड आउट फॉर द 24 hours and these number that can be plotted against time that give a certain characteristic curve and that curve is called as growth curve. This is a figure of a growth curve. In examination, the question may ask define growth and explain the different growth stages in the bacteria. Means when you can plotted this is the number of bacteria. We suppose this is 10 number of bacteria, certain phase that will be constant. After that will be the exponentially grow in that particular media. After some time, the growth of this bacterial phase or bacteria that will be completely serious, or the growth rate that will be birth rate that is equal to the growth rate. Sorry, birth rate that equal to the death rate, and after some time the death rate that will be increases over the birth rate that show the decline or death phase. लक्षात घ्या, पहिली जी आहे व्हेन यू कॅन प्लॉटेड इनॉक्युलेशन, म्हणजे तुम्ही इथे 10 बॅक्टेरिया टाकल्यात. काय केल्या, 10 बॅक्टेरिया टाकल्यात. 10 बॅक्टेरिया टाकल्यानंतर सर्टन पेज मध्ये त्या 10च्या 10 राहील. 10च्या 10 राहिल्यानंतर काही आफ्टर सर्टन टाइम, काही वेळानंतर दॅट शुड बी एक्सपोनेन्शियली ग्रो. मीन्स 10 दॅट कॅन बी मल्टिप्लाय इंटू द 100. म्हणजे इन दिस फेज, इन दिस एक्सपोनेन्शियल फेज और द लॉग फेज, द रेट ऑफ बर्थ इज मोर ॲज कम्पेअर्ड टू द रेट ऑफ डेथ. इथं डेथ होण्याचं प्रमाण काय होईल, कमी राहील ॲज कम्पेअर्ड टू बर्थ. सो these graph that show the straight curve. After some time or at a certain stage, the growth rate or the birth rate that equal to the death rate. म्हणजे 10 नवीन तयार झाल्या तर 10 त्या ठिकाणी डेथ होईल. At that time that show the stationary or the stable curve. After some time we going to take the observation. In this phase the death rate is more as compared to the birth rate. म्हणजे 10 तयार झाले की 100 मरतात. कर्व काय होईल, त्या ठिकाणी डिक्लाइन किंवा डेथ फेज येईल. सो व्हेन यू कॅन प्लॉटेड द नंबर ऑफ बॅक्टेरियल सेल अगेन्स्ट टाइम दॅट ऑब्टेन अ कर्व दॅट इज कॉल्ड एज ग्रोथ कर्व. नंबर ऑफ सेल अगेन्स्ट टाइम म्हणजे त्या टाइमला त्या किती सेल होत्या याचा जर तुम्ही ग्राफ काढला, that gives a certain curve. That curve is called as growth curve, and there are 4 phases. There are 4 phases in that particular growth curve, that is lag phase, log phase, stationary phase, and death and decline phase. That is the same. Death or decline is the same phase. That is 4 number of phases in the growth phases in the bacteria. That is lag phase, log phase, stationary phase, and last one that is the death phase. So what about lag phase? आता तुम्हाला या स्लाइड मध्येच मी समजून सांगितलं पाठीमागच्या स्लाइड मध्ये की लॅग फेज काय आहे आणि लॉग फेज काय आहे. लॅग फेज काय आहे, द बॅक्टेरियल पॉप्युलेशन व्हेन इनॉक्युलेटेड इनटू न्यू फ्रेश मीडियम डजंट मल्टिप्लाय इमिडिएटली बट टेक सम टाइम टू ऍडजस्ट टू द न्यू एन्व्हायरमेंट. म्हणजे तुम्ही 10 बॅक्टेरिया त्या ठिकाणी टाकल्या, ती 10 बॅक्टेरियाच्या लगेच मल्टिप्लिकेशन सुरू होणार नाहीये. दॅट टेक सम टाइम टू ऍडजस्ट टू दॅट पर्टिक्युलर एन्व्हायरमेंट. त्या एन्व्हायरमेंटला ऍडजस्ट करण्यासाठी काही पिरियड त्या ठिकाणी जाणार आहे. दिस टाइम पिरियड ऑफ द ऍडजस्टमेंट ड्यूरिंग व्हिच बॅक्टेरिया डोंट डिव्हाइड but synthesize the cellular components. That is called as lag phase. म्हणजे ते डिव्हाइड होत नाही म्हणजे ते ऍक्टिव्ह नसतात असं नाहीये. दे आर मेटाबॉलिकली ऍक्टिव्ह. ते ऍक्टिव्ह असतात and they synthesize the cellular compounds and that is called as lag phase. The cell size increase the bacteria have the largest size in the end of phase. At the end of lag phase, bacteria becomes fully prepared for cell division and the cell division that will be started. म्हणजे लॅग फेज संपण्याच्या वेळेस त्या पूर्णपणे तयार असतात डिव्हिजन साठी आणि लॅग फेज जिथे संपेल तिथूनच सेल डिव्हिजन स्टार्ट. सेकंड, that is called as log phase or the exponential phase. In log phase, bacteria divide continuously at a constant rate and the number increases exponentially. लॉग फेज मध्ये काय होते, बॅक्टेरियाचं कंटिन्युअस डिव्हिजन त्या ठिकाणी चालू असतं कॉन्स्टंट रेटनं आणि नंबर जो आहे बॅक्टेरियाचा तो मोठ्या प्रमाणात वाढतो. दॅट इज कॉल्ड एज एक्सपोनेन्शियली और सो इट इज कॉल्ड एज एक्सपोनेन्शियल फेज. मोठ्या प्रमाणात अतिशय प्रचंड प्रमाणात त्या बॅक्टेरियाचं काय मल्टिप्लिकेशन त्या ठिकाणी चालू असतं कॉन्स्टंट रेटनं आणि त्याचा कर्व जो आहे तो स्ट्रेट होतो. इन दिस पिरियड ऑल द बॅक्टेरिया आर इन देअर स्टेज ऑफ अ डिव्हिजन बिकॉज ऑफ व्हिच दे आर हॅव द स्मॉलेस्ट सेल साइज. मग सर्व बॅक्टेरिया त्या ठिकाणी काय असतात डिव्हिजनच्या स्टेजमध्ये असतात. Bacterial population is most nearly uniform in terms of their number, metabolic activity, chemical composition and other physiological properties of the cell. The lag phase is followed by the log or exponential phase when the bacterial cells start dividing and their number amplify exponentially with the time. Lag phase झाल्यानंतर log phase येते. In log phase when the bacterial cells start dividing and the number amplify exponentially with time. टाइम जसा वाढत जाईल तसं त्याच्या मोठ्या प्रमाणात बॅक्टेरियल सेल त्या ठिकाणी वाढतात म्हणजे नंबर वाढतो. लक्षात घ्या 10चे 100 100चे 1000 त्या फेज मध्ये त्या ठिकाणी. देन नंबर थर्ड दॅट इज स्टेशनरी फेज. When the bacteria that can be grow continuously in a log phase, their density that will be increases, concentration of the nutrient decreases and various secondary metabolic products begins to accumulate in the medium. Bacteria grow continuously in log phase, the density that will be increases, concentration of the nutrient decreases. म्हणजे एखाद्या न्यूट्रिएंट मीडियम ज्या न्यूट्रिएंट मीडियमवर त्या ठिकाणी तुम्ही ती बॅक्टेरिया ग्रो केलेला आहे त्यांची जी न्यूट्रिएंटची संख्या आहे तुम्ही आर्टिफिशियल न्यूट्रिएंट देताय. काय देताय, आर्टिफिशियल न्यूट्रिएंट देताय. मग तिथं संख्या वाढल्यामुळं त्याचं कॉन्सन्ट्रेशन आहे न्यूट्रिएंटचं काय होणार आहे डिक्रीज होणार आहे. म्हणजे 1 किलो समजा एखादा पदार्थ आहे 1 किलो आहे 2 जणांनी खाला आणि 100 जणांनी खाला, द क्वांटिटी ऑफ दॅट पर्टिक्युलर nutrient that should be decreases. Likewise that when the bacterial density that would be increases, that automatically decreases the nutrient. तिथले न्यूट्रिएंट काय होतात कमी होतात. प्रोडक्शन ऑफ an antibiotics such as penicillin, streptomycin and enzymes by certain bacteria occurs during this phase. मग antibiotics काय आहे, that is the substance that will be secreted by one microorganism that helpful to kill the another microorganism that is called as antibiotics. So in this phase the bacteria that can be started the antibiotic production to kill the another bacteria. त्या ठिकाणी बॅक्टेरिया काय करतात दुसऱ्या बॅक्टेरियाला किल करण्यासाठी अँटीबायोटिक प्रोडक्शन त्या ठिकाणी या फेज मध्ये स्टार्ट करतात. This condition bring the stationary phase of the growth curve. In some cases there is a complete cessation of the cell division and there is neither increase nor decrease in the number of bacteria, that is no net increase in the population because the death rate that will be same as per the birth rate. या सेल मध्ये काय होते डिव्हिजन त्या ठिकाणी कंप्लीट स्टॉप होते. दे बॅक्टेरिया दॅट कॅनॉट बी इंक्रीजेस कॅनॉट बी डिक्रीजेस. काही वेळ ते डिक्रीज पण होत नाही इन्क्रीज पण होत नाही. दॅट द नेट पॉप्युलेशन दॅट विल बी सेम, दॅट इज कॉल्ड एज स्टेशनरी फेज. इन अदर केसेस सम बॅक्टेरिया डिवाइड and some die and hence balance each other and the number of bacteria that remain the same. In endospore forming bacteria, sporulation that also occurs at the bacteria enters in the stationary phase. And last one that is the death phase or decline phase. शेवटची जी आहे ती कोणती आहे death or decline phase. In decline phase the number of bacteria decreases continuously. The bacterial number decreases exponentially which is just opposite to the log phase. लॉग फेज मध्ये जसं एक्सपोनेन्शियली बॅक्टेरियाची नंबर वाढत होता त्याच सेम फॉर्मॅट मध्ये इन केस ऑफ अ डिक्लाइन और डेथ फेज in death or the decline phase, the number that should be decreases as exponentially grow in a log phase. Means this death or decline phase that will be the opposite to the log phase. जशी log phase मध्ये increase होते तशी death phase मध्ये काय होते, decline phase मध्ये त्या ठिकाणी exponentially decreases होते. The death rate in the decline phase is slower than the growth rate in the log phase. Death rate हा decline phase मध्ये तो काय असतो, slow असतो as compared to the growth rate in the log phase. During this phase, total count of the bacteria may remain constant, but the viable count that will be decreases. Not all the bacteria die at the same time in decline phase. Some die faster and some which are more resistant remain viable for a longer time. बॅक्टेरिया एकदाच सर्व मरत नाही, काही फास्ट मरतात, काही रेजिस्टन्स फॉर फॉर्मेशनमुळे व्हायबल फॉर द लॉंगर टाइम, म्हणून तो कर्व स्ट्रेट नाही तर थोडा काय असतो, तिरका त्या ठिकाणी येत असतो. दिस इज ऑल अबाउट द डिक्लाइन ऑर द डेथ फेज. नेक्स्ट, जनरेशन टाइम. द डेफिनेशन ऑफ जनरेशन टाइम, द टाइम रिक्वायर्ड बाय द सेल टू डबल इट्स नंबर, दॅट इज कॉल्ड एज जनरेशन टाइम. जनरेशन टाइम कशाला म्हटलं जातं, द टाइम रिक्वायर्ड बाय द सेल टू डबल इट्स नंबर. एका सेलचा नंबर डबल होण्यासाठी जेवढा वेळ लागतो दॅट इज कॉल्ड ॲज जनरेशन टाइम. म्हणजे एका बॅक्टेरियाचे दोन बॅक्टेरिया होण्यासाठी जेवढा वेळ लागतो दॅट इज जनरेशन टाइम. द टाइम रिक्वायर्ड बाय द सेल टू डबल इट्स नंबर, 10 बॅक्टेरियाचं 20 बॅक्टेरिया होण्यासाठी जेवढा वेळ लागेल दॅट इज कॉल्ड ॲज जनरेशन टाइम. दिस इज अनदर डेफिनेशन इन दिस चॅप्टर. ओके, थँक यू फॉर युअर अटेन्शन. हिअर we completed, that is the nutrient required for the growth of a bacteria as well as the bacterial curve, that is chapter number